I remember it was a Saturday morning when the first images arrived from the Webb telescope. We all got up early and opened our computers and we downloaded these images. At first we just saw black and white images, and later on we were able to piece them together into color images. And they were much more dramatic than we'd anticipated. Titan was discovered in 1655 by a Dutch scientist, Cassini-Huygens, very famous polymath scientist, and he found Titan looking through his telescope when he was looking close to Saturn.
He was also the first to observe the rings of Saturn at the same time. And he named it Titan because it was thought to be the largest of the moons in the solar system at that time, partly because of its dense atmosphere and extended atmosphere. It took some time before it was realized that Ganymede is actually a little bit larger than Titan.
Yeah, so Titan's a slowly rotating moon. It takes about 16 Earth days to complete one rotation. Because of that, its atmosphere overturns in a very slow way. It also has 30 Earth years to make 1 year on Titan.
Don't tell Jupiter, but Saturn might be my favorite planet in the solar system because it's so beautiful and because of its ring system, but also because it has such an incredible variety of icy moons. It has Titan, which is so strange. It's almost like an Earth, but totally different with its thick atmosphere, thicker than Earth's atmosphere. And it's got rain and lakes and rivers, but not of water, of liquid hydrocarbon, which is just, again, mind-blowing.
I fell in love with Titan years and years ago with the first image of Titan, which was like a big orange ball around Saturn. And it was an enigma from the beginning because we were all interested to find out what was under those clouds that we could see surrounding this wonderful body.
We had several flybys, Pioneer and Voyager missions that really started to finally get us some of the information that we had about Titan, let us know that this was such a special and unique place.
My interest in Titan began with the Voyager 1 close flyby of Titan in 1980, in the fall of 1980.
Good morning. I want to welcome all of you to JPL and to the beginning of what is going to be clearly a very exciting mission. We're going to have to operate under a very strict fund ceiling, one that is imposed by Congress, and an unyielding schedule.
I was then a student and I started working on this mission and the instruments, the payload that it was going to carry. And we decided on what exactly we wanted to explore. So we had on the one hand, the NASA spacecraft. That was the orbiter called Cassini. And on the other hand, we had a little probe. Not so little, actually, 300 kilos weight. So we had Huygens, that was going to be a probe that was going to be launched inside Titan's atmosphere and go all the way down to the surface. And we started looking at what kind of architecture we wanted for a mission, what kind of trajectory. And we looked at all the different options and we put together this amazing adventure and mission that became the Cassini-Huygens mission.
The first time I saw the spacecraft together, when we stacked without the blankets, I must have stood in the visitor gallery for 30 minutes. And I don't know how to describe it. It's not yours anymore. Even though I had been intimate with each piece and part of that spacecraft and put it together wire by wire and part by part, to watch it come together as a whole entity was incredible. We were without words standing out there.
Every now and then we'll be working in here and you'll think, wow, this is going to Saturn, and this probe's going to land on Titan, and this is going somewhere where we've never seen things before, and you get goosebumps from it.
FLC, we have steps 325 and 326 complete. Roger. EA and LCC, 327, 328 on time. EA, Roger.
LCC, roger.
The Air Force Launch Controller has given a clear to launch. We've got
go from the range to proceed with the countdown.
Launch sequence started.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. Its program is in.
All transport stations. Launch vehicle report stage 1 ignition and SRMU jettison.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn.
So with Cassini-Huygens, we really got our first great view of what the surface of Titan looks like, kind of in a few different ways. The Cassini orbiter orbiting Saturn made over 100 flybys of Titan using different wavelengths that could peer through the haze, as well as radar, was really able to map the surface and give us an idea of some of the diversity of the surface features.
And you're watching live coverage from the Jet Propulsion Laboratory in Pasadena, California. Tonight, the Cassini spacecraft has its first close encounter with Saturn's largest and most intriguing moon, Titan. This is the closest we have ever been to Titan, and over the next 5.5 hours, we hope to see the best images we have ever seen of Titan. And here on NASA TV, you will see those images just minutes after they actually arrive on the ground.
Cassini was really, for 30 years, a major part of my research program.
Anything stand out in your mind at this point?
Yeah, it's been a very strange evening. If you put me against a wall and said what's cloud and what isn't cloud, I really couldn't tell you. I assume that much of this is surface features.
Cassini was a remarkable mission because not only did it discover amazing things, but it actually followed up on its own discoveries with genuinely different observations. So some of the most spectacular discoveries were that Titan has methane lakes and seas on its surface, the equivalent of the Great Lakes, for example, on the Earth, but not with water, with methane and some other organic molecules.
That's how we could discover the equatorial dunes, polar lakes, some of the mountainous features.
And where you saw some of the stuff coming in, was clearly stuff to be seen there on that surface. Understanding it's a different issue. We knew Titan was a tough target, was going to hold its secrets tightly, and so we designed this mission and the experiments to hit it with everything we've got.
But with Huygens, we got our most close-up view and our first real feeling of what it would be like to stand on the surface of Titan.
The moment I'm speaking, the probe is about to finish its descent towards Titan.
When I was waiting for Huygens to land on Titan in January 2005, it was like, it's as if you're expecting the delivery of a baby. It was like, oh, I hope that it all goes well. And we had a little glitch with one of the channels that wasn't transmitting the data when we were expecting it. And with Jean-Pierre Le Breton, who's the project scientist of Huygens, we were so anxious because for a scientist, there's nothing better than getting data. And we started observations with the orbiter. And then in Christmas, we launched the Huygens probe into Titan's atmosphere.
The probe team is also ready to go, so we are waiting for tomorrow. So let's go.
I was a graduate student at the time studying Titan when Huygens made its descent. I even remember, we had a lot of bets going around. What was Huygens going to find? What was it going to measure?
I'd like to start the poll in 5 minutes. Command timers, both online is fine.
I knew you'd have another control.
He came for when we received the signal. That's the important thing.
Got it all.
When will they acquire the signal?
Earliest carrier lock is 7.
That's right on the money. Right on the spot. It's like exactly.
I can say, because I was there when Cassini arrived in late 2004, and 2005.
The heat shield has not burned through. It has held on and has protected the Huygens probe, and the parachute has deployed, and this is the carrier signal telling us that now there's communication between Huygens and Cassini.
When we saw the first images that came back from the camera on board Huygens, we saw immediately that none of our models, none of our predictions, nothing in our imagination had prepared us for the diversity that we saw really on Titan's surface.
I was there, so this was one of the most memorable moments in my career, I would say. Assuming that all goes well and we get the science data, I think Titan is such a fascinating world and Huygens is so well equipped to study it that we will remember this day as we remembered Voyager. I was there with about a dozen other people, and when the data finally came into the terminals in that trailer, it was in the form of hundreds of thumbnail images.
The parachute opened from the Huygens probe around 100 miles above the surface, and then it was able to descend, kind of swaying slightly from side to side under its parachute, and actually ingest part of the atmosphere as it descended and kind of sniff these chemicals and determine some of the constituents of the atmosphere. And then it took images, especially as it got closer to the surface, around 15-20 miles up, was able to see not only icy mountains, but kind of carved river channels where there appears to have been ancient flowing rivers of methane on Titan's surface.
There were river channels on a hillside, river channels on this cold, distant, icy moon.
It was really dramatic. We didn't quite know what to expect. In fact, the Huygens probe was designed for multiple different types of surface landing. It was designed even to float if it landed on a sea or an ocean. But as it turned out, it landed on a dry surface, thought to be kind of a bedrock of water ice, but covered in a hazy material, which is
and the complexity of Titan's system.
So Titan's a really exciting place, and just because we sent the Cassini-Huygens mission there does not mean that we have all the answers already. In fact, there are many questions raised by the mission that we still need to answer. Some of those pertain to the chemical complexity of the atmosphere. Does it create chemicals which could be the seeds of life? There's also many questions about Titan's weather, and why is it that there are lakes and seas only in the northern hemisphere and not in the southern hemisphere? There's also questions about Titan's interior. Does it harbor a vast interior water ocean, and could there even be life inside Titan as well as on the surface? So really many outstanding mysteries.
So what James Webb Space Telescope is able to do for us is to continue the observations over a longer period of time.
JWST now, which is an amazing tool that people think only looks at galaxies and stars, but we use it for planetary investigations. JWST is going to get us so much more information on Titan and this kind of small bodies that are very far away from the Earth. We need big telescopes, and We are discovering a lot of new things about the composition of the atmosphere and the surface every day. JWST is helping so much.
The giant planets, though, have their own retinue of moons, some of which, turns out, have liquid water under their surfaces. So this makes for a very rich system where there might be environments where life perhaps could exist beyond the Earth. So one of the outstanding questions, and one that Webb can help us answer, is whether there are habitable environments in the outer solar system, in the moons of the outer solar system, that we can study up close and perhaps even find evidence of life.
It's just been wonderful to watch the new data come in, and also equally wonderful to watch the teams working together to try to figure out what it means, like the Titan team.
Okay, great. Well, again, thanks for allowing me to speak at this exciting JWST first year workshop.
Well, congratulations to the whole team. It was a work of many, many people to help with all these integration times and settings and team effort since, I think, 2016 when we first submitted this. Yeah, it seems like there was some excitement this morning. Everyone logged in their computers and got some pictures of Titan. It's almost like being back on Cassini all over again.
And they get this JWST data, and it's just like, whoa, look at this. And watching them kind of argue over things and like, well, no, it can't be that. Well, I think it might be. Let me check this. It's really fun to watch that all been happening. And that's been happening sort of across the solar system.
So the Webb telescope, unlike the Hubble telescope, views in longer wavelengths. That's what we call the infrared, or the getting into the heat part of the spectrum. And because of those longer wavelengths, Webb is able to penetrate to different depths in the atmosphere compared to Hubble. And that reveals different layers of the atmosphere. So using the Webb telescope, we've seen clouds at different altitudes coming and going. We believe convecting, possibly even raining out on the surface. Seeing really fantastic detail here on Titan from these processed Webb images from November. Our very first look at Titan from the Webb telescope. There's this vast dune field here called Bellet, which is a hydrocarbon sand dune field on Titan's lower latitudes, like a vast desert. And then in the northern regions here, we can see these two really large cloud events that are really going off here, close to where the lakes are located, the famous methane lakes of Titan. We've also been able to use a Webb spectrometer, which is a part of the instrument that can split apart light into different wavelengths or frequencies, and has been able to tell us a lot about the chemical composition of the atmosphere that we didn't know previously, including we can now see Titan's methane actually breaking apart in action and forming into new chemicals. We've been observing Titan with Webb now for almost 2 years. We're expecting to get new observations this year, which should reveal if there are changes in the seasonal weather patterns, if the clouds are moving from where they are right now in the mid-northern latitudes and moving towards the equator to the south. We're very excited for next year when there may be equatorial storms, such as we're seeing with the Cassini mission around 15 years ago at the last equinox. So it'll be a really exciting time to observe and see if there are these big storms coming back on Titan.
From space with JWST, we detect new things. We find new molecules because we have the technology improved. But there is absolutely nothing in my mind that would compensate or be a substitute for further exploration of Titan.
After we've submitted all of the material we developed to try to prove to NASA and the review panel that we felt Dragonfly was, going to be a successful mission, we had to wait several months for the NASA associate administrator, all of the leads of the different divisions, to review all of the materials, look at the recommendations, and they were choosing between 2 missions at that time. So we were semi-finalists. We found out few days ahead of time when the announcement was going to be made. And I remember it very distinctly because I was at a scientific conference, and it was the astrobiology science conference. They set up big TVs in the largest, like the ballroom at the conference, and everybody at the conference came in and didn't know what the answer was going to be. And up on the TV we had the administrator at headquarters, and then it was very dramatic. It was very made for TV. And then they said, and the next
New Frontiers mission, Dragonfly.
The whole room, it felt like everybody jumped out of their seats and was like screaming and cheering and so excited and hugging and all of these things. And then I got to go up on stage with some of the other team members and you know, make a little bit of a speech just talking about how excited we were about the mission. It was like my own version of an Oscar speech as a scientist. That's probably the closest I'll get to that. But it was like truly magical. It was a truly magical way to learn that the mission was selected.
So Dragonfly is the size of a Mars rover. It stands, you know, about this high, and it's about 10 feet long. So we're used to drones that are, you know, small things that we fly around in our backyards. Dragonfly is really a Mars rover-sized drone that will be able to fly from place to place on Titan.
The atmosphere is dense. It's about 1.5 times the surface pressure of Earth. There's a low gravity. It's about 1/7 the gravity of Earth. And so that actually makes it really favorable for the kind of heavier than air lift that you get with you know, a drone or a helicopter type flight. And so the mission is designed to go and visit several locations on the surface of interest. That includes the equatorial dunes, which we think have a lot of these organic sand particles, and also a former impact crater where there had been liquid water in the past after the impact, but it's since frozen over. But we want to know, you know, what kind of chemistry took place in that location for the time when you had the liquid water present.
But this drone idea with Dragonfly is going to be extraordinary, and it's going to look for all kinds of biosignatures and other components that we can find on the surface, because the Huygens probe was not designed to land. But this time we're landing and we're going to get the information we need about the composition of Titan's surface. What is there exactly on the surface? And how does this translate into the features that we see on the surface?
About a decade from now, we'll be getting ready, hopefully, for its landing and figuring out how to navigate the surface of Titan remotely. So when we get the first images back from Titan, it will be one relief. Okay, we did it. We landed. And then I think it's going to be just, wow. And what's that? And what do we think that is? I know to expect the unexpected. I keep telling everyone on our team, every time we talk about this, no matter what we plan for and no matter what we expect to measure, we're going to get there and it's going to totally change everything. And we're going to find something that we didn't expect, and we're going to have to, you know, pivot and think about things in a whole new way. But again, that's the fun of it. And that's why, you know, you want to go and you want to go with all the best tools that you have, and then you have to be ready to react to what you find.